Problem 8. In this multiplication, L, M, and N are different digits. So what is the value of L plus M plus N? So because L, M, N are digits, so then L, M, N only can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's look at the multiplication here. So first step is M times M. So N's in M. Actually, it's not equal to M. Its unit digits is M. So we have M digits times M equals to M, okay? So unit digits is M. So let's look at these digits. Which digits could give us this result? Okay, so we can have M could be first one. Of course, is 0 times 0. Wait, okay. 0 times 0. So equal to 0, right? So 0, if M is 0, so these are all be 0, then cannot be 5. So not consider of this one. So 1 times 1 is also equals to 1. So if it's equals to 1, M is equals to 1. So here 1, 1 would be 1, but L would be times 1. If L is 5, that's fine. So L, this one is a 1, but you multiple by 5, this should be 5. And you won't have N, so 1 doesn't work. Okay, so then we could have 5 times 5 equals 25. See, they ends into same digits, 25, right? So this is possible, and 6 times 6 equal to 36. Okay, so we then have two choices for M, and which is 5 and 6. And we don't have, 2, this ends in 4. 3 times 3 is 9, 16. 7 is 49, 64, and 81. They are all ends in different digits. So we only have these two choices, 5 times 5, 25, and 6 times 6, 36. Okay, so let's check 5 first, okay? Say M equals 5, so then we have 25, right? We have 2, we plus 2 here, okay? So then we multiply by L, then S2 equal to 5, so we have 5 times L multiple by 2, add 2 equals 5. So no, ends in 5, okay? The unit digits is 5, not equal, okay? So the unit digits is 5. So then we have 5 times L equals to, you subtract 2, so unit digits would be 3. So because we multiply by 5, so all the number, any digits, multiply by 5, so you ends in either 0 or 5. So that's impossible, ends in 3. So then that's 5 is not the choice, okay? So this is also not possible. Okay, so then let's check 6, the last digits, okay? We hope it works, okay? So 6 times 6 is 36. So we have 6 here, we add 3. Then we have 6 times L plus 3, and equal to some number, ends in 5. So then we can have 6 times L equals to some number, ends in 2. So let's look at this digit L, if this could be, okay? So we can, L could be 2, right? 6 times 2 equals 12. So, okay, L. So if M equals 6, actually, this is not possible. So we have M equals 6. So L, so then L could be 6 times 2 equals 12, right? So this is 2. And 6, okay, times that is not 18, 24, 30, 36. Okay, 42, 7. So 42 ends in 2. Okay, so we could have 2 or 7 for L. So let's check 2 first. So if L is 2, okay, so 6 6 times 2 plus 3, so it's a 15. So we do have 5 here. So then we add 1 here. Okay. So L is a 2. So 2 plus 1, so it's a 3, but the N is supposed to be 6. So 2 doesn't work, okay? So this one doesn't work, okay? So we have to check L equals to 7. Okay. So let's check 7. Okay, so we have 7. Okay, so 36 plus 3. So 6 times 7, 42. Okay, so we do have 5 here. So then L equals to 7. So 6 times 7, 42 plus 4. We do have 6 here. So N equals 4, right? So, okay, so then we have L equals to 7 and N equals to 4. So L plus M plus N is 7 plus 6 plus 4, 17. So the answer is 17. D. Problem 9. Peter, Emma, and Kyla play chess with each other. Peter won 4 games and lost 2 games. Emma won 3 games and lost 3 games. And if Kyla lost 3 games, how many games did he win? So, okay, so we have Peter. Let's organize the information. So we have Peter, Emma, and Kyla. So we have wins and we have loses, right? So we don't have a tie. We just have win and lose for 1 game, okay? So Peter actually won 4 games and lost 2 games. And Emma won 3 games and lost 3 games. And Kyla lost 3 games. And the question is, how many games did he win? Okay, so we know if the 1 game, because we don't have tie, so we'll have 1 win and 1 lose. Okay, so if we would have N games, so we should have the N wins, right? And the N lose. They should be equal, wins and lose. Okay, so here we have how many loses we have? Total is 8. And the wins has to be 8 too. So the Kyla must win 1 game here. Okay, so answer is 8, 1 game. Problem 10. Robert made 5 statements A to E. Exactly one of these statements is false. Which one? So A, my son Basil has 3 sisters. B, my daughter Anne has 2 brothers. C, my daughter Anne has 2 sisters. D, my son Basil has 2 brothers. E, I have 5 children. So these 5 statements, and we can find out B and D actually contradict to each other. So why? Because if Anne has 2 brothers, and because Basil also is a boy, so Basil has 2 brothers, so Anne should have 3 brothers, right? So these 2 contradict to each other. That means these 2, one of these 2 statements is false. So these 2 statements, one is false, one is true, right? So let's say case 1, okay, B is false. Let's assume B might be false, okay? So case 2, D is false, okay? So let's check, is that possible? Okay, so B is false, so A, C, D, E are true. Okay, so let's look at these statements. The first, my son Basil has 3 sisters, okay? Basil, 3 sisters, sister 1, sister 2, sister 3. And C, my daughter Anne has 2 sisters. So, okay, so let's say this is Anne. Anne has 2 sisters, okay. Anne has 2 sisters. And my son Basil has two brothers. So Basil has two brothers. So we will have B1, B2. Okay. So I have 5 children. So then E cannot be true because there are a total 6 children here. Okay, so that doesn't work. Okay, so this assumption doesn't work. Okay, so let's look at the case 2. D is false. So if D is false, so A, B, C, E are true. So A, my son Basil has 3 sisters. Okay, so Basil, 3 sisters. Sister 1, sister 2, sister 3. And B is also true. My daughter Anne has 2 brothers. Okay, so Anne is here. So Anne, okay, as 1 sister, has 2 brothers. So then B, we have 1 more boy here. Okay, so C, my daughter Anne has 2 sisters, which is also true. And E, I have 5 children, and E also true. 1, 2, 3, 4, 5 children, right? 5 children. Okay, so E is true. So that it works, okay? So then the conclusion is D is false, okay? D is false. So our solution is also, answer is also D. Problem 11, the total weight of a bucket of oil is 21 kilograms. After Jason has used half of the oil, the total weight becomes 12 kilograms. So what is the weight of the bucket in kilograms? Okay, so we have a bucket and full of oil. So that is a 21 kilogram. Okay, so after Jason used half of the oil, so we have a bucket with half of the oil. So 1/2. So then that is 12 kilogram. Okay, so by subtracting the 12 from 21, so 9 kilogram, that is half of the oil, the weight of half oil Jason used, right? So oil, weight. Okay, so then we know 9 times 2 equals 18 kilogram. It's the whole oil weight. Okay, then we have total weight of a bucket of oil is 21. So 21 kilogram minus 18 kilogram. So we have 3 kilogram, which is a weight of bucket. Okay, so which is C. Problem 12. What is the minimum possible product of 3 different numbers of the set? Okay, so we have a set. So we need to choose 3 numbers from this set, and their product is minimum. Okay, so because we have negative number in the set, so our product, the minimum product should be, we could know, is less than 0, right? So, okay, so we have 3 number. So we multiply by them. So the product less than 0. So the case 1, we will say, okay, they are all negative numbers, okay? So then we just have 3 negative numbers. So then would it be negative 8 times negative 4 times negative 6 and negative 4. So this would be less than 0, okay? And all we have, case 2 is we have a number is negative and 2 number is positive. So 1 number is less than 0, 2 number is greater than 0. So this also will give us the product is less than 0. Okay, so let's see, we can have negative 8. Let's make this as minimum as possible. Okay, so negative 8, so times 5 or times 7 times 5. Okay, so that also will be negative numbers. So it is obvious -7 will even don't need to multiply by all of them. Should be less than -8 times -6 times -4 because 35 is actually greater than 24. So, but it's a negative number. So this number would be less than this number. Okay, the product. So then let's just multiply this number. So that is -280. Okay, so our answer is B, -280. Problem 13. Suppose that 6% of the 8th graders and 3% of the 7th graders at Washington Junior High participate in math counts. There are 2 times as many 8th graders as 7th graders at the school. What percentage of the 7th and the 8th graders taken together participate in math counts? Okay, so method 1, non-algebra. So let's just give 2 numbers to the 8th graders and the 7th graders and in the Washington Junior High. So let's say, so 8th grader, 8th number of students, let's say it's 200. And the 7th number of students, it is 100. Okay, so what percentage of 7th and 8th grade taken together participate in the math count? Okay, so then we know 8th grade, 200, so times 6%, that's equals to 12 students participate in the math count, right? So 100 times 3% and equals to 3. So 3 students of 7th grade participates in the math count. So the percentage, so we know equals to part of a whole, right? So the part equals 12 plus 3 over total students of 8th and the 7th taken together, 300. So that's the 15 over 300. Okay, divided 100, 5. Okay, 5%. So the answer is 5%. Okay, so that's the method 1. Okay, so equals to 12 plus 3 over 100 plus 200 equals 15 over 300 equals 5%. Okay, so method 2, algebra. So we can set variable. So let's say the number of students, 7th grade, number of students is X. Okay, so then 8th grade, number of students is 2X. So how many students, how many 7th grade students participate? The math count is X times 3%. So how many 8th grade students participate math count is 2X times 6%. So then we have percentage equals to 3% X plus 6% 2X divided by total students of 8th grade and the 7th grade, X plus 2X. So that would be 0.03X plus 0.12X, okay, over 3X. So that equals 0.15X over 3X. So then we can actually cancel the variable X equals 0.15 over 3. So that is 1, that is 0.05. So 5%. Okay, so 5% is our answer, so C. Problem 14, 2 dice are thrown. What is the probability that the product of the two numbers is a multiple of 5? Okay, first, let's review the probability formula. Equals favorite cases over total, or events, okay? Favorite events over total events. Okay, so we need to calculate the total events and our favorite events, okay? So we have 2 dice, okay, it's a D1 and a D2. So we know the sample space for 1 die is 1, 2, 3, 4, 5, 6. 1 also for D2, 3, 4, 5, 6. So the total is, we have 6 ways, and we have this 6 ways, 6 choices. So total is 36 pairs of number. Okay, so we need to find out how many pairs of a number among these 36, which the product of the two numbers is a multiple of 5. Multiple of 5. Okay, so let's say D1, if we have 5, then D2, we can have any number from 1, 2, 3, 4, 5, 6. So that we will get the two numbers, the product of two numbers is a multiple of 5. So total is 6 events or 6 pairs of number. Okay, so D1 also can 1, 2, 3, 3, 4, 5, 6. So D2 is 5 if. Then we also can have 6 pairs of number, which the product of two numbers is a multiple of 5. So it looks like total is 12, but wait, did we overcome some number, some pair of number? Okay, actually yes. Okay, so look this, 5, 5, 5, 5. So 5, 5. This pair of number we count twice. So then the total favorite pairs events actually 6 plus 6 minus 1 is 11. Okay, so then we have the probability equals to 11 over 36. So which is D.